Today I am talking to Ryan Fleury. Ryan works at Epic Games on the Rad Debugger project and writes blog posts about programming on his Substack. He also has extensive experience in programming games and in software development tools with heavy experimental elements. I have worked personally with Ryan on a number of projects, and that actually poses a bit of a problem for a podcast like this because it means we have a lot of shared language and shared context about ideas. And for a general audience, it's important to make sure that you can follow the conversation. So we do our best not to rely on our own jargon here. If it gets a little bit in the weeds or a little bit too abstract to follow, I do apologize. But I think a lot of the things that Ryan and I have discussed in the past are things that we would like to be able to share with other people. And so I try to ask him questions to get him to explain things in fresh ways. And it works to some degree in parts of the conversation. And we struggle in other parts to come up with a fresh way to explain our ideas. But I still think that there's a lot of value in it. We discuss Ryan's blog posts regarding UI. He has an extensive series on his experiments and his perspective on how to build a UI system. We talk about interesting aspects of his UI system, like whether it prioritizes quality for the end user or ease for a developer or performance, and what the reusability story of the system is. We talk about the idea of a core and builder code portion of a UI system, and we explore the complex topic of defining and using the terms top-down versus bottom-up in the space of programming. And finally, we wrap up by talking a little bit about the future of computing and what UI systems might be like in a more idealistic computing environment. I hope that this conversation is of use and interesting to you. And without further ado, here's Ryan. So I'm here with Ryan today to talk about UI programming. Ryan has a blog where he talks about lots of different programming topics and has a fairly lengthy, in-depth look through how he programs UIs. At the time of recording, there are 9 posts plus I think 1 bonus post, so a total of 10 posts on this topic. And before we get into sort of like looking into how you think about UI programming and how you got to the style you've got, I want to just ask, what was the on the blog series itself? What was sort of the motivation or the reason you came to decide to write such an in-depth UI blog like series? And is that still an ongoing thing? Because it's not clear how much more you might still have to say. So I'm curious to get that squared out first. Like, what's the story with the blog, how it went, and how it's going in the future?
Yeah, I think so. UI programming is one of those things where I never considered it the primary goal of what I was doing, but I wrote a lot of UI for various tools or games or game engines that I built over the years, or, calling them game engines is maybe a little bit strong of a word, but, I'd make level editors or tools for building files of some kind that I need. And over time, I tried to refine it every single time. I mean, it just became clear that I was very interested in it, and in doing a good job at it, partly because it always seemed like a daunting problem. And so I ended up just really refining it and rewriting, I guess what I would say is I didn't continuously reuse the same UI code base from project to project. I would always be interested in revisiting it. And so I think it was one of those things where I looked at UI stuff, and it's one of the things where I feel pretty confident in my ability to write a solid UI. And I wanted to package up those lessons, and because I didn't see a lot of posts describing the full breadth of things that I had to encounter and try to solve when I was building my own user interfaces. So I guess that's why I started writing it. Is it felt like something I was pretty good at, felt like something I had a lot of stuff to say about, and what better to write a blog series on than something like that, I guess. And I had also just been doing a lot of UI programming. I mean, obviously at work, but also like every personal project felt like it was just hitting the same UI stuff over and over again. And it was really like, it just started feeling like I had a lot built up to say, and I knew what I was going to say, and it wasn't very vague. So I was like, let me just write this so people know sort of what my perspective is on it. I think it's a very popular topic because a lot of people, especially in sort of the handmade circle or handmade like community and adjacent, they either are familiar with immediate mode UI programming through DRI and GUI, or they try to write their own. And there's a lot of confusion about a lot of things, I think, in that space. And I think I had done enough work to answer at least several of those things for people. So that's why I ended up going there. But yeah.
And how do you think it has turned out so far? Do you think people are like sort of getting the benefits of the lessons that you tried to pass on?
Yeah, I think so. I've seen a lot of good progress made by people who have read the blogs. I think other people seem to be happier with it than I am. I think it feels like one of those things where I'm not unhappy with it per se, but it's one of those things where hindsight is 20/20. And so you produce this big thing and you're like, maybe there was a more elegant way to introduce this topic or something. I mean, there's so many threads to the whole problem, and not all of it was planned, obviously. So I should say not all of it was planned at the beginning, and then I had this whole plan and knew exactly what piece was going to come up when, and then I went and wrote everything. It's been an ongoing process, so I kind of add on to it when I have enough material to put out a new post. But I think overall it's been a net positive. I don't think a lot of confusion has come from it, and I think a lot of the more subtle ideas that have informed the way I program UIs, I think those have come across as well. Like, people are starting to get a lot of the stuff that's been very difficult for me to communicate for a long time. So it felt like it was definitely the right medium as compared to like long Discord conversations that seem to not go anywhere. And like, so I would say net positive. Hindsight's 20/20. I would probably tweak some things if I went and did it again, just like a UI code base, I suppose. But yeah, so.
Yes, I'd definitely like to spend some more time later looking at those deeper lessons, the sort of philosophy of programming / meta process stuff that you're alluding to. But I'd like to spend a little time starting on the sort of the surface of this stuff and talking about the UI system you've kind of built up. It's a little hard to describe. If you haven't read the blog post and you're listening to this, it might be worth it to go read the blog post to know exactly what we're referring to, because we're not going to rehash the blog posts speak for themselves. So I'm going to assume a little bit of knowledge for a little while here, but I'd like to try to make a summary of the kind of UI system you're describing in your blog post, because UI programming is this space where there's a lot of different sort of constraints, or at least things you would like to optimize for, pulling at you in different directions. So it creates a fairly high dimensional trade-off space. And just off like the top of my head earlier, I wrote down a few of the things that I could think of that come up. So one of them is the ease that the programmer has to creating new UI with the system. There's the quality of the UI that the user ends up interacting with, and that's both you can break that down to the visual quality, the how good the interactive experience is, and how well it conforms to their expectations and the norms versus how well it optimizes for their inputs, which are all things you discuss in the blog, and the trade-offs in those, just that quality, like super point alone. And then there's also the performance of the UI. There's which pulls against both the ease of programming and the quality of the interaction experience. And then on top of that, and you already mentioned this thread too, there's this reusability thing of how much, like, on one end of the spectrum, you could get a library like DRI GUI and just try to do none of the core UI each time. And on another end of the spectrum, you could write a brand new UI system every time, which it kind of sounds like you're sort of in that second camp where each UI you've worked with was a new, fresh slate with some of the same ideas imported, but then iterated on. And so, you're building this UI system, and there's all these different things you could optimize for and things you could sort of set aside or sidestep. And I want to try to get an idea of how do you locate the type of UI you're advocating or describing in your blog posts?
Yeah, that's a really good question. I think for me, I've never wanted to compromise. I think my approach is from multiple iterations of trying to get the best of both worlds. And obviously that's not practical in all circumstances, but I find myself I don't easily arrive at the idea that we should compromise final UI quality that users interact with for the sake of the programmer. But within the space, like if you have the whole set of solutions to some user interface problem, and there's some subset which produce the best quality, or like, you somehow can classify each solution as like how much or how high of quality does this solution have with respect to what the interface pops out and how nice it is to use as the user ultimately. And then within that space, there's still trade-offs of how easy is it going to be to program this thing. And in some, I would even say that it's not necessarily mutually, so like it's not necessarily a trade-off space, in that if you make it easier, for example, to produce user interfaces, then you can iterate more quickly on a design as well. And so that could actually improve the quality, and like it's not exactly clear how all these things relate to each other, but I think I don't like to... I fundamentally disagree with the idea that you should compromise user experience for the sake of the programmers writing it, but within the space of like, I'm trying to produce the best thing I can, how do I increase my iteration speed, and how do I try to get the biggest bang for my buck?
Mm-hmm.
I guess I would start with that idea, and I think part of the reason I approach it with that perspective is that I think sometimes people assume things are binaries or trade-off spaces when it's sometimes possible to get the best of both worlds, and it's sometimes possible to have your cake and eat it too.
Mm-hmm.
You don't necessarily always have a trade-off. Sometimes you just do, and then at that point you have to make like careful decisions. But I've always tried to approach things from, let's assume I can get both of these things, and then at some point it becomes clear that I can't, and then at that point I'll decide. I don't like to assume that I have to degrade the final interface quality unnecessarily.
Yeah. So let's zoom in on that question of quality for just a minute, because there's another interesting UI design thing that comes up, which is you're not building UIs using like the operating system layers, combine the UIs kinds of thing, where if you were using that, the quality that you would get in terms of layout and design of the actual sort of flow of whatever form is still up to the programmer. But the quality of the graphics and the interactive experience and the adherence to norms would basically be whatever is provided by the OS. And you are building all of your stuff, you're not going that route. You're going the route of it's our own thing. It's not going to look and feel exactly the same as the OS ones or the text fields you get in the browser. There's always a possibility that some weird corner cases behave slightly differently, like the drop-down menus on the top of your window might have a slightly different behavior, or if you're tab cycling with the keyboard through widgets, it doesn't quite hit the same logic that the Windows tab cycler would do. But for the most part, it does look like you were just saying, you go for things that look good and that behave pretty close to like within 90% of your expectation. So I wonder what is your calculus for the value of hitting that 100% expectation level versus trade? Because that, I don't know, would you agree that you do trade off a little bit of that total emerging in order to get some other things? And what exactly is the justification for that trade off there?
Yeah, I definitely think so, and I think it's when it's not very satisfying of an answer, I would say. It's probably whenever I have an opinion that the operating system did a bad job at something. Like, everyone knows how it feels to use like the Windows File Explorer dialog, like you hit, Control O, or like you hit File Open or whatever, and it pops open this window, and like you try to hit Control Backspace, and then it like makes a little square, and you're like, that's not what I meant, and and then you have to like use your mouse and switch back and forth between your mouse and the keyboard and everything. And I think in those cases it's worth diverting from maybe the established standard, although in many cases it's also not worth diverting. Like in the case of keyboard input shortcuts, I won't claim that I get 100% of them, but I try to shoot for like 95% plus. Maybe that's just my answer. It's like I diverge from the standardized decisions whenever I feel like there's a win. That could be in terms of like some deeper design principle, in the sense of like, I really would like just a solid file browser that behaves a little bit differently, but it doesn't require me to switch to my mouse at all. Or I want this drag and drop behavior that the default Windows controls don't have, but it seems like an obviously good idea. I think that unless people want to be bound by the decisions that Microsoft has made, for example, if you're shipping on Windows, it's Microsoft. If you want to be bound to their decisions, which it's hard to know like what set of decisions, now given that there's like several layers of UIs in Windows now. But I mean, if you don't want to be bound to those decisions, you're sort of going to be writing things yourself from scratch. And then at that point, yeah, I mean, within that space, I think whenever there's a well-established pattern that doesn't compromise on some other design principle, I think that at that point it's worth shooting for. Yeah, I guess that's probably what I would say.
Yeah, I mean, I don't have an example of this because I don't generally, like, I just don't spend that much time looking for the weird corner cases in the Windows UIs myself. But I do wonder about things like, for instance, in my experience working on 4Coder, one of the hardest things to figure out was how to make people happy who were inputting text in a different language. And that's something where you get these things where one sort of concern that can be raised is that, well, these operating system ones have just tons of baked in paths that different users are relying on. And your thing has 95% of the paths, in the sense that that's not like it's pretty unlikely for anyone to notice it. But it's possible there's actually like 50% of the paths are missing. It's just that those are super rarely used and only by specific kinds of users. So it's hard to say whether that counts as a quality, like a trade-off against quality. And it sounds to me like what you're saying is that there are, on the one hand, there's a bunch of things that are in those. So even if you do buy into the idea that there are some quality losses from picking to do your own thing, what I'm hearing you say is there are some quality losses just from picking to do the Windows thing. Because even if it has these cool features, it also has such major problems that this 95% path that you're optimizing for is better off, even if you lose these sort of special things that the Windows UI might have a bunch of extra work put into to handle them. So I don't know if that clarifies my question, but it does sound to me like that's sort of the answer to the thing I was looking at.
Yeah. I think that's a really good point. When it comes to like text input in other languages and stuff, I certainly don't hit the mark to the same degree that Microsoft does, for example. I think when it comes to that stuff, I try to think about it in terms of, I would agree with your characterization, first of all, that you do lose quality when you go with the established like technology already, and you also cut out a lot of potential wins, I would say, on like multiple fronts. In order to be more specific, we'd have to like dig into some details, but you also do lose a lot of, like, for example, accessibility features. There's ways to, I've like never really approached this, but obviously there are native accessibility APIs, there's native text APIs and everything that I don't really conform to. And I think when it comes to that stuff, it's a matter of trade-offs. It's like, how many people, what is your target market, and how many of them are writing in these other languages, and how many hours will you spend working on those problems, and how it's like bang for buck in terms of effort, I guess. Now, some people are have a very pure perspective about that kind of thing. Like, we will have 100% all native input and native text rendering and for like multilingual support and everything. And I think duplicating all of that in like a total from scratch solution is not really viable. And I would call that a degradation in quality, maybe, although at that point it is sort of a trade-off. It's like, do you want to spend maybe worse full multilingual support, which is, if you're at least, like in my case, it's like a fraction of the people that I would send my software to, like a very small fraction. In 4Coder's case, it's more difficult, right? There's a lot of people all around the world who like are writing software in this thing.
Right.
And so, I don't know, for me, it's like, it's worth spending that degradation in quality for these other possible benefits in quality.
Mm-hmm. Well, I think that it's a tricky situation, but the answer you're giving that makes sense to me is that it is a trade-off at that point, and it's not clear that you would actually be better off getting those features for free from the native layer because of the things you would lose to take that path, is basically what I'm hearing.
Right.
It makes sense. So let's talk a little bit. I want to sort of move us gradually into the space of not the style of the UI you're talking about building, but the techniques you're using in building it. And I think a good in-between point to visit there is how your reusability story works. So you can imagine a couple different ways of packaging up and reusing a UI system. I think a library is pretty typical, and you could also imagine like a more framework kind of thing. I think people call Qt a framework because it involves a little bit more establishing the shape of the entire application when you go to Qt. And of course, at a certain extreme, there are other options that take us outside of the realm of C++ programming entirely. But I kind of count that as a totally different like space that is not close enough to what you're doing to even be relevant. But within that spectrum between, DRIM GUI and fully custom integrated into my code base so deeply that it can't be reused in any meaningful way, how would you think about the way you do reusability?
Yeah. So I think I definitely don't go the full knot of like any UI code I write is like multi-layered ultimately, and I would say there's like a UI core layer which I describe, and there's sort of this like differentiation between core and builder code, and the core is sort of solving like the smallest kernel of problems that I would care to solve for the purposes of implementing user interface, and I think like that is still not necessarily. It's not really like application specific at that point. So I still segregate things by like, this is my like core UI layer. It's doing all the things that I would like to assume for every time I write a UI within this code base. And then that kind of proliferates upwards, I guess, through like this tree of code that depends on other code inside of a code base until you get to sort of the application-specific code, in which case none of it will really be reused, or almost none of it. If it does get reused, it's going to be totally transformed. So maybe to try to answer that in a little bit better of a way, I would say I still find it valuable to separate UI problems that generally apply to user interfaces from specific applications that need to implement user interfaces. So I still have like a UI layer ultimately, is what I'm saying. But I don't go, so I don't go the full route of like bundling it all into one knot. Like this is just this code base doing all the UI, and then the next time I have a game or application that I'm writing, I'll just write it all again from scratch, kind of thing. Instead, I think I do it more on like a per code base level, and I think that's partly because user interfaces, by their nature, bundle so many various systems and requirements into one whole knot of stuff that has to work. Like, if you have a rendering layer and an audio layer and like an operating system abstraction layer, which like gives you the ability to receive input from the user or open windows or like all that kind of stuff. If you have those layers already, the UI is sort of the thing that bundles all of those things together. And of course, it's also heavily related to like strings and text rendering and like memory allocation. Like it's sort of, it has to touch so many things of the code base that I still find it worth it to have that as a first class layer inside the code base. Like I don't package it up as a library, just because I think that there's quite a bit of friction and cost that comes when you do that. Just because if you do ship UI like tools or machinery as a library, it has to either ask user code about so much, or it has to make those decisions itself. And so I think that's what happens with like DRIM GUI, for example, goes the library route, and as a result, like you can't tweak certain things without rewriting many parts of the library. If you're very opinionated about the way things animate or show up on the screen, like you have to go and basically start reshaping it into being more of a first-class thing of your own code base. And if there are any decisions that you don't like about like the way DRIM GUI does something, it's like it gets further and further from like little reusable library that you just like repackage up, and you can update it when it gets updated by the developer or whatever. So I think for that reason, it's really been more geared towards like developer debug tools where people don't need to make all these like very subtle modifications to it. Just because the opinions about the way something shows up, for example, doesn't really matter at that point. And then all the way on the other side, as you said, like there's Qt, and they don't go the library route because they have to make all of those decisions for themselves. So instead of asking user code about like, or passing data back to the user code for like rendering or something like that. They're just like, we're just going to make all the decisions about the way strings happen in this code base, and we're going to deal with the way things show up on screen, and we're going to provide all of these tools for you to be able to like customize that. But it's like, at the end of the day, a Qt code base is different from a non-Qt code base. Qt really has a very opinionated stance on shaping the code base. And so for me, I'm like, let me write the UI that I find valuable for this code base. And if I ever move to a different code base, then I would maybe like, my reuse would not be like, take the old UI code and just duplicate it over here as this like helper library or something. It would be like, okay, we're just building a new UI layer. Maybe I can pull some code over and transform it so that it fits like the styles of how some things happen. But for the most part, it's like, I want the ability to specialize the UI core on a per code base level. Now within one code base, you can still have multiple applications. Like one code base is not necessarily like one game or one tool or one application. It could proliferate into several tools. But I'm somewhere in between, I guess. If that's a spectrum, then I'm somewhere in between those two endpoints.
Yeah. I'm hearing that maybe I wouldn't call it a trade-off, but an affirmative decision away from high reusability style solutions where your code can be exported as is to a new context without your knowledge, and it works. Like, that's not a part of the design constraints you're actually accepting. Your designs kind of reusable part is almost just the conceptual layer of how this thing works, but you're not expecting the code you write to transfer into new contexts in any sort of way, or to like create in the Qt way. It's not so much, or Qt framework way. It's not so much a matter of transferring it so much as just dominating, like becoming a starting point for lots of them. So you're not also, I suppose another way to say this is, it's not also like you have an app template on GitHub, but what you're talking about in your blog post is also not that. It's a thing you would write from scratch in contexts that already exist, rather than being a starting point for an application. Although I suppose you could imagine having such a starting point.
Yeah, for sure. Yeah, like, so if I went to my app template and like implemented a sort of a shim of UI layer, or maybe just like a full, like, here's the UI layer that just does the default stuff or whatever that I find reasonable or something, and here's how you make a button and all these helper widgets or something, that would be fine. But I think what's important is that whoever sort of has control over the code base also should have control over the UI core and how things are layered into it. And that's not true when you take something like a library, because, I mean, it to some degree is true. I mean, if you import DRIM GUI and then you're like, I'm going to go change the way that this happens, or I'm going to not use the default widgets and like just build using the lower level APIs inside of DRIM GUI, I'll build it this way or something. But I think when you do that, it moves further away from what a library would have been, where a library is like, just like... Yeah.
Right. I mean, there's a certain ambiguity there where it was a reusable library when you grabbed it, but it stopped being that as soon as it became conceptually dependent on stuff in your context. It stopped being transferable and became basically the same pattern you're talking about with your own core. Yeah,
for sure. And I think, I don't know, with UI as a problem, it's got such a large surface area. Like, the set of possibilities you want to achieve with a user interface layer in a code base is so broad. It's partly just because of the nature of the problem. The fact that you are facilitating communication between a human and a computer. There's so many ways for that to happen, and there's so many established patterns for doing that. It's like, there's just a ton of stuff that you kind of have to do. And I feel very uncomfortable personally about sort of giving up control over that to someone else and like not worrying about it. And I think anytime I have tried to do that in the past, I've always been like unhappy with my experience. It's sort of been like, this is like kind of ridiculous. Like, I have this context that I can use in this case, and just within the context of the code base, like, this is the way I do strings, this is the way I do memory allocation, this is the way I do rendering. The repackageability of like UI layers does impact all of those things. And so I think I've always had an aversion to just giving up full control over that to someone else. And I mean, ultimately, I think half of it is the fact that when I sort of grew up building these tools for my games, I was always both in the chair of the person writing the user interface and in the chair of the person using the user interface later. And so I care a lot about the way the code feels to write, but I also care a lot about the way it ends up looking and feeling and animating on the screen. Even if in many cases you might not care about those things, I'm like, I don't know. I want to enjoy those things. And so I just didn't want to lose control over some of the details that you do with library reusability.
Yeah, makes sense. I think that kind of sets up another question for me, which is you've referred a few times now to your sort of core UI layer, which is it was something you talk about in your blog post and is distinct from what you call builder code. Can you start by just giving a quick recap of what that means, what the two different buckets of code in a UI system are, the core and the builder code?
Yeah, so the idea of builder code is anytime you're designing an interface, or I think how I call it in the blog post is sort of a cohesive interface design, meaning you're building a form for some reason, or like you right click on an entity in your game level editor and you want to see like all the settings for that entity or something. The way I conceptualize it is builder code would be anything that's making decisions about how that UI shows up. So like a concrete, like this is application specific kind of thing that you're encoding into builder code. And that's opposed from core code, which is implementing helpful machinery for producing consistent effects for the builder code. So the core is sort of the machinery of like, you said there was going to be a rectangular portion of the screen here that animates when you hover over it and you can click it and it like has text attached to it or something like that. And it's animated like this. And these are the features that you can put onto it and everything. That's sort of like the core. You could call it like the UI engine layer, maybe. I don't know exactly what word to use, but I called it the core code. And then builder code is anything like, okay, given the tools that have been provided to me by the core, let me build some cohesive idea about a user interface. Either like a fragment of a user interface, like even just a simple widget, I would call, for example, like code that implements a color picker. I would call that builder code because it's using like, okay, these basic features that are provided to me by the core. Clickability, I can render things in certain ways. I can lay things out in certain ways. Using those tools let me implement the idea of a color picker. And then, of course, you can get higher and higher level and more and more application specific, where at the highest level you have like, yes, your entity editor thing for your level editor, or, you know, depends on what application you're writing, but obviously all the application stuff happens there.
So if I could just traverse that same ground again to make sure I've got it. So there are some things that are clearly core to your system, and they're core because they're basically the building blocks that if you build something on top of these building blocks, then that's using the UI system. And if you can't build what you want on these UI blocks and so you write new code, then it's like kind of an extension outside of the UI system entirely. Like no longer even the UI system, it's a new solver for a new problem. But this core thing has those core solutions, and then anything outside of that boundary that's just the core building blocks, the language you've just sort of developed for constructing UIs, everything outside of that is building on top of it is the builder code. And so the widget example is the color picker widget example is interesting because it does not have, like, in my head, when I think builder code, I immediately start thinking like, okay, application specific, I've got a level, I have an entities tab, and I have a sounds tab, and I'm switching back and forth between them to get the things all figured out. And you're saying, well, there's also builder code that is actually not bringing in any context besides the fact that there's a UI system and the idea that we want a color picker, and there's no application context in there, and yet the thing that describes how I build a color picker is actually builder code and is not like a part of the core UI stuff that defines that widget. That's how you're drawing that line there, right?
Right. So I think another way to say it might be that with each layer in this step from like the UI core all the way up to the highest level application specific code, you're sort of adding bits of context every time. And the idea there is basically for reusability, because you want to, if at any point someone made decisions about the way something worked that you disagree with in this chain of like sort of layers that make certain assumptions, the idea should be that you can ditch those and step outside of whatever box or whatever boundaries they drew. So the reason I find it valuable to like separate, for example, like these basic helper widgets or whatever into their own like sort of, it's like builder code technically, but it's not application specific builder code, and they make like a small number more assumptions than the core code does, but not enough to go to the point where they're like, yeah, like here's the entities tab, here's the sounds tab, or whatever. Mm-hmm. And the reason why I think that is useful ultimately is because if, for instance, if I'm in my application specific layer and I have some other style of color picker that I want, or some really, I think this happens a lot with buttons, because if I'm putting a button in a UI, it feels convenient to be able to say like, here's a button, here's the text on it, and then you're done, and then the user can click it or something. But really, there's like a million more things that arise when you actually do that. It's like, okay, is there like an icon rendering in this? Or maybe it shows the tooltip of the hotkey associated with the same action, and maybe like that's its own complicated UI. And maybe when you hover it, you want to show a tooltip, and like all of these things start piling up. And then at some point, you want to just be able to go like, screw the default button. Like, let me just shift over to my own context where I have a lot more details than the helper widget layer did. But that doesn't mean I have to throw out the entire UI layer. I can still like use the basic machinery of the core, but then now I just have this separate button code path. So I guess that's why I would say that differentiation is useful, where like, you know, you can have a family of like helper widgets, and those can do some common patterns, maybe to just get up and running pretty quickly. But you don't want to bury those so deep into the system such that they're in the core. So if you do disagree with any of the decisions there, you have to throw out the entire thing and build a whole custom thing. Like, at least you can start with the core and build up from there.
Oh, that's so interesting. I feel like what you just iterate or like propose is that what makes the core reusable is that these other things are disposable, right? Like, the fact that you can be done with this particular color picker because it doesn't fit in the space where you need it, and you need a condensed one, you're going to write a new one from scratch, and that's not baked into the core, is a part of what makes the core reusable, right? It's weird. It's like it's almost like instead of code reusability, it's like code disposability is like the same thing from a different angle or something. I have to think about that more.
Yeah, for sure. I think that's over time what I've found is that there are certain things that I always want to reuse with UI, and there are things that I never want to reuse. And like a good example of the stuff you never want to reuse is like application specific, like very tied to the context of whatever it is you're building one day. But the things you kind of would like to reuse inside of the context of a single code base is like, here's the way that borders in UI show up, or here's the way that rounded corners with a background and drop shadows show up, and this is what it looks like when you hover them and click them, or something like that. Like, that's context that I don't necessarily want to throw away all the time. And so the core is sort of meant to make the minimal set of decisions it can without adding a ton of extra context, and just provide useful tools within that space of like just providing tools for building interfaces. We're not going to assume that much. And and I think there's something about the lack of assumptions that the core makes that does make it reusable, because I don't know. I mean, as you remove assumptions from something, you make it more and more generic, I suppose. And so the core becomes more generalized, the fewer decisions it makes about things like very specific widgets or very specific designs. So
So again, this is one of those things where I think a listener who's listening and hasn't read the blog post is going to have a hard time picturing some of this. But I do want to just say that it's a little bit easier to picture what Ryan's talking about with the core if you understand just the key idea of what Ryan's doing, which is essentially that your core UI thing doesn't have widgets. And there's a whole blog post in your series about this. But can you explain what you do have since you don't have widgets, just so anyone who's trying to wing it kind of knows what we're talking about?
I think maybe I could probably like tell the story of how I evolved my style into the place where it is today, and maybe that would clarify it a little bit. So I think when you first watch, or before that, you're building a game and you're trying to put some buttons on the screen, like play, settings, quit, and then when you click settings, it like goes into a settings menu or something like that. When you're doing very simple stuff like that, the first thing you think to do is take whatever high-level effects you were shooting for and just write those features in the simplest way you can. And this is like the early advice you get from sort of the handmade world is like, no, just like write the simplest code to do the simplest thing that you wanted to do. And that's how I started. Ultimately, it's like, oh, I need a slider. So let me write a slider in the simplest way. Like, here's the rectangle, and then if the mouse hovers here, then like you just do that thing from scratch. And you do the same thing for every sort of bundle of effects you want. So you have buttons and checkboxes and radio buttons and sliders, and the list goes on of all these like widgets that you implement. And you've sort of got separate code paths for each possible kind of widget design. What ends up becoming very clear is that all of these widget designs overlap in very non-originally obvious ways. Like the idea that dragging a slider is ultimately the same interaction, like the same sequence of interactive steps that clicking a button would be, is like maybe not obvious on day one. And similarly, like with, checkboxes, it's probably a little bit more obvious because it's like, oh, it's a button, but it's attached to this like separate state or something. But there's a lot of things like that where it's like, it's not obvious that clicking is the same as dragging, and it's not obvious that. Another example of that would be like clicking and dragging text within a line edit or something like that. It's not obvious that would be the same thing on day one, so you don't really write it that way. But over time, what happened to me is I like looked at all this and I'm like, I'm writing the same clicking code path like 8 different times. And of course, like then you have this like compression-oriented programming instinct kick in, and you're like, oh, let me pull that out into a helper function. But the simplest way that I eventually... The simplest thing for me that I eventually went to is like, let me just make it all one code path. Let me assume that I can have all the UI features at every node in this hierarchy all at once. So I'm going to write clicking once, and then I'm going to like leverage that in multiple ways to get like all the effects I want out of it. And so I think what became obvious to me at some point was buttons, checkboxes, sliders, radio buttons, etc. are all special cases. They're sort of specific points inside of a space of possible widget options, and when you bury them all the way down into the core, like you have widget kinds that are sort of buried all the way in, it starts becoming clear how you have to like take one of those specific designs and like tweak it a little bit, and like, no, I actually want a button, but it's also slightly different. It's like more like this, and like the interaction changes here in this specific way. And so what ends up being the most flexible thing is like not making a button or a checkbox a first class thing. Instead, you just want to build this idea of like a node, and it's going to show up on screen, and I can have specific interactability features that I want to attach to it. I want this thing to be clickable. Here are some ideas about how it shows up on the screen, and given that machinery, so hopefully that communicates the idea of like, there's no widgets. There's just like this data structure that has some relationship to like rectangular portions of the screen, and it has some relationship to like interactive code or interaction code paths like clickability and scrolling and stuff like that. And using that basic machinery, that's located in the core. Using that, you can produce the effect of a button, and you can produce the effect of a checkbox and a radio button and everything. But those aren't first-class ideas. Like those are helper, like builder code layer stuff.
Mm-hmm. Yeah, so I think that's a pretty good coverage of the issue. If anyone's listening and you like got the basic idea that there's this data structure and it corresponds to rectangles on the screen and interactive code paths, then that's like the core stuff. But if that doesn't sound like enough description to go and build a UI system, that's what the blogs are for. Because there's a whole lot to actually the details of how that works. But that's the main thing I wanted to make sure was just sort of in there, so that when we're talking about builder paths, code paths, I think it's a little bit more clear if we know that there's this thing in the core. It's not empty, but it's not widgets either. It's sort of more primordial somehow than what you might expect from other UI systems you've looked at before. So I think that relates to another question I wanted to pick your brain about, which is what is bottom-up design and top-down design? How do you think about those two terms, and how does that, because that shows up in your blog as well, and I think it's related to this design decision about how the core works with a core data structure. So like how do you think about those two terms and how they influence your thinking process?
Yeah, for sure. So I think top-down design, I didn't call it this in my spiel, but when I was talking about like you have specific widgets in mind and you go and implement those widgets and you sort of one for one, you write a code path per widget that you want. I would describe that as top-down design because you're picturing the thing that you want on the screen and you sort of have this high-level model of what it is you're interacting with. And you start with that, and this is also how like a lot of like it seems like corporate programming has gone this route as well, where there's they have like user stories, and they're like, well, we need a user flow, and the user's goal in this interaction is to like create a user account or something, or log in, but they forgot their password or something. Like they pick out this very specific high level idea. And the code is written to service this high-level idea directly. That is different from, I suppose, what I would call bottom-up design, where the idea is to give rise to the space of possibilities, that one of which is the high-level design you wanted. And the idea behind building the space instead of like the final point is that you don't necessarily know what the final point is, right? So there's like this space of possibilities in the software you're building, and you think that you have this idea of like, oh, this is the point that I want by the time I'm done. And so like, this is the way it's going to work and this is the way it's going to flow and everything. And then you go and build that thing. And then suddenly you realize you're like, actually, this isn't quite good enough. Like I actually wanted it to be slightly different. Or, what happens when, the user hasn't forgotten their password, but they forgot their email. Like what happened? Like, there's like tweaks you can make to this point in this space of possibilities. And if you just built everything, like this whole rigid structure just to service that one final idea, then you have to throw the whole thing out. And then you have to build the whole thing again. And the idea behind bottom up, in my mind, is building a space of possibilities that you think is a reasonable approximation, or you can reasonably estimate to contain the points that you care about. And so when you produce that space, then it's much easier to sort of flow within that space. So this connects in with the widgets idea, right? Because when the UI core is built without making assumptions like we're building widgets and sliders and checkboxes and everything, really what it's building is a bunch of composable features that can come together to produce those effects, but they can also produce this whole other space of like weird buttons that scroll a little bit, or the possibilities are sort of endless at some point. And when you do that, then you're no longer limited by the original like tower of design decisions you made to get to this one point. You have space, you have room to breathe, and you can play with the final point you get to.
Yeah, so I think it's a good starting point. I'm maybe flesh this out a little bit more with some questions. I'm thinking through sort of how that's hitting me. So I think one part of that it sounds too good to be true, but I think that there's a little bit of missing information about how you mean this, that you're constructing this space. So in the top-down design story, it's very pointillist. Like you've got your set of points, and you go down and you check off. We implemented this user flow to that point is checked. Then we go to the next point, and once each one is implemented, the tasks are done, except that then we review them, and all the points get shifted a little bit, and then it happens again. And so from your story of the bottom-up design situation, it's as if it sounds like you're saying first you construct the entire space, but that sounds too good to be true in the sense that so now you have every possibility implemented simultaneously, or what is when I can understand what the space is, which is like all the different possibilities of slight variations of the I forgot my password situation are in the space somehow. But in what way are they constructed, since I don't literally end up with a UI for every combination just in my UI in my application somewhere? Right, like, so I think that's the part that's maybe would help a little bit, is when you are talking about this bottom up thing and you're sort of and there's a separate question that maybe would be a little easier to answer first, which is how do you even go about giving rise to a space rather than picking a point. Maybe we can figure out from the way you're giving rise to a space in what way the space actually exists when you're done.
Yeah, that's probably a good place to start. So I think the way that I try to think about it is, well, I suppose it comes down to like a phrase that I've like heard my brain say before as I'm programming, and I don't know, it's fuzzy and I don't know how true it is, but like I think about this when I'm thinking about this like problem, I guess. Which is that if you have code that is doing too much, it's much easier to stop it from going down certain paths, versus you have code that does not do enough, and now you have to somehow incorporate this new feature or constraint into the picture of what it's like doing, but possibly not doing it. And so I think like what ends up happening with UI is like, instead of assuming that you're like building to that one point, you sort of build with the assumption that this thing will be pushed to its absolute limits, right? So you're like, look, we're just going to have like, I don't care about buttons, I don't care about sliders, like you're just building like crazy UI trees with all these features, and like one widget or one node in this tree, like one box on the screen can have all these features equipped. It's like you can scroll it with the mouse wheel, you can click and drag it, you can drag and drop somewhere else, like it has all these animations attached to it, like all of these are possible. And then you could actually go and do the math, right? I mean, given some number of features, you can find out like how many possibilities there are. And like at the end of the day, when you only wanted a button, that's one of, 2 to the n possibilities for n features or something like that. But that building the space of options to the point where you can easily move from one point to another inside of that space of composed features or something like that, that gave you a lot more freedom, and it also prepared the underlying machinery to just do a lot more than something that was built for one specific point. And so I think the way I think about it is like, build the underlying machinery to do a lot more than you expect and handle a lot more at once, and handle all of these problems simultaneously in one big bulk thing, rather than building some special case thing, seeing it's not enough, and then having to go and like refine that and be like, how am I going to handle this case or something like that. It's like, instead just build the thing that handles everything. Everything. Of course you can't do everything, but you can do a lot more than building the one specific point. And so that's sort of what I meant by like, you're trying to produce a space of options that you can easily move between, and that space should hopefully contain the things that you will care about, or you can estimate, like, I don't know exactly what the design should be here, but I know that it can be one of these like 30 options or something, and I can achieve all of those with these 3 building blocks. And so if I like do that, then you can go and easily like, turn on this feature, and I'm like, I don't like that feature, so let me turn that off, and then turn on this other one. And you can like mix and match and like jump between points in this possibility space that you come up with. And to be very concrete, what I mean by this, and I describe this in the blog posts, it's just writing one function that does all the features at once, and like, in the right order and everything, and then you just apply a mask to it. And then there you'd have like bit flags, and instead of masking like bits or data or something like that, you just mask portions of this code path off, and then it becomes very easy to be like, okay, turn on that part of the code path, see what happens. And it's like, I don't like that, turn that off, and then you can play with it at that point much more easily.
Yeah, so to map this back onto what you were talking about with the core a little bit more tightly, if I'm understanding you correctly, this mantra that you have of it's easier to stop code that's doing too much than to get code to do more than what it's doing. That mantra kind of maps onto this thing you were talking about, I think, and correct me if this is not the way you mean it, but this thing where you have, clickability and animation and whatever other features that are, they're more primordial than the concept of a widget, but you could make a button out of them or you can make a slider out of them. And so you have all these features, and you're talking about basically building one system that does all of them for every entity always. So every box is clickable, every box animates, every box is everything. And then you would just turn that off selectively to actually get the effects that are more appropriate for different cases. Is that the right mapping of the two things to each other?
Yeah, definitely. And I think a good example of that too would be like a very common assumption might be, for example, that a label inside of a UI does not need to be clickable. But that's not like, maybe that's not always going to be true. Like maybe at some point you do want to get a little bit closer to Windows and you say like, oh, I want someone to be able to like click and drag within this label and select the text. Like it's not a text field, you can't type into it, but it's like, this label has some text in it and I want to be able to click and drag here and like Control C or something. That's an example of like on day one, you're like, oh, here's just some text showing up in the UI. But, on day 200, you've decided that you have to slightly tweak that point in the possibility space for that label and be like, actually, no, I do want clickability on this thing. Like, let me make it so that the user can click and drag here. And it doesn't cause the whole thing to come crumbling down. That's just another node in this whole uniform tree that can, quote unquote, do everything within the space of possibilities, obviously. And, you haven't really, like, the problem hasn't changed that much at that point. But if you had all these assumptions built in, like, oh, well, a label is, like, in this particular case, it's what shows up next to the checkbox, and, it's not exactly this node that can have all this other features loaded onto it. It just becomes a lot less weird to approach the problem from the perspective of handling everything and then, like, squeezing down the final... building a code path to do everything and then like turning things a bit off, basically.
Mm-hmm. Do you find when you're building UIs with a system like this and you're doing this thing where you've got these features that you're adding to the core that are sort of in the sense that every node in the core structure is going to support all features? Do you find that you run into conflicts there, like that there are certain combinations of these features that if they're not masked off in appropriate ways, you would get like either egregiously bad, like cause a crash kind of problems, like just these two features literally are incompatible, or they just there's sort of redundancy? Or do you find that is like, I guess another way to phrase this question is, I'm wondering if I'm listening with the ear of someone who hasn't built code this way before, is there a downside or like difficulty in building that system? Because without digging into it, it might come across again like a little bit too good to be true, the idea that I could just implement all features in one code path and that wouldn't be a problem. So is that not a problem? Is it easier to deal with than you think, or it never actually comes up in practice, even though you could imagine it in theory? Or what? Like, what's your understanding of why that kind of thought doesn't bother you?
Yeah, I think theoretically it definitely could be a problem, but I think it depends on how you sort of parameterize this space. If we're sticking with like the linear algebra like analogies here, what are the base axes that you're forming the space with? So, and this has to do with like, I've called this before, probably incorrectly. Mathematicians would probably like slap me or something. But I've called it orthogonality, and maybe that's not technically correct, but I think it gets at some picture of what I want, which is like, do these features do they overlap with each other in some fundamental way? Meaning, like, if you have a clickability and a dragability code path, which, by the way, I originally did implement things that way. I didn't actually... Initially, I was like, clickability and dragability in UI are fundamentally different operations. And so I had those two things. And yes, at some point I started to see, like, yes, these are duplicative. And so I think writing code this way actually gives you some insight. It's easier than you might think to like be in the middle of writing it and being like, oh yeah, this is doing literally the same thing as this block up here that does this other feature. And I'm like, is there some different way to decompose that space? But I mean, I've never been in a situation where it's like things will just crash. I think Theoretically, you could have two features that will conflict in that way, but I think when you're forced to write code in this way of like, no, we're doing everything all the time, you don't really put yourself into a position where that happens. And furthermore, what I would say is that if you cared about some of these richer combinations of features, and there was going to be some complex ordering problem of like, this has to happen, then this has to happen for all of these nodes over here, and that, which this doesn't happen in UI, but in some complicated problem, you're like, this phase of work has to happen before this phase of work. If we do work A for all things and work B for all things, that's preferable, because if we did work A for one thing and then work B for another thing and then back to work A for the first thing and then work B for the second thing, if we did it that way, then there could be performance costs, or there could be like, yes, then you could run into like, there's just logically incorrect results here that happens, and it could lead to, logical bugs or crashes or whatever. Point being, if you were in a problem space where you cared about that combination of features, you had to solve the ordering problem anyways. And so by being in the position where you have to deal with like all the features firing on all cylinders at once, you sort of have to solve for that constraint from the very beginning. And so ultimately in practice, like there can be cases where I'm like, how do these two features exactly work? And maybe I changed my idea for how they decompose exactly, but I've never really been in a situation where I'm like, there's no way to make this work ultimately. So hopefully that's...
I think that does help. That does help sort of satisfy. I hadn't even thought through before the aspect of that where you could imagine a situation if you were doing the top-down design and you have your button and you have your scroll bar, so you got to click and drag, and maybe you have another click and drag for a slider, and then someday your UI ends up in a situation where you simultaneously want to click and drag something and then activate an effect on the drop that is not just the final, with the scroll bar, the final effect is just it stops moving, and so the dragging is done. But you could imagine very easily, like, the drop does activate something, and now it's just the activate of a button and the drag and drop of a drag and drop happening in the same widget.
Right.
And if you had implemented that as two paths that were both trying to capture the mouse input and one was overriding the other, that would be a conflict. But you were going to have to build a whole third widget if you were doing this top down and solve that problem anyways. And so what you're doing is basically saying, whatever problems you're going to solve, make them all look like the same problem.
Yep.
As often as possible. It makes sense in a way that I'm going to have to think about before I can articulate super clearly. But yeah, I think that does help a lot.
Yeah, for sure. And there's a concrete example of that too, by the way, which is like, if you click the Windows sound thing, or the Windows sound thing, and if you're like testing your audio in your headphones or something, and you click and drag the volume and you release, then you get this sound playing in your headphones.
Right.
And it's like, if you didn't have a slider there that was controlling the volume, you would think that's a button. Like, it's just a button, but it also has this dragability thing tacked onto it too. And I don't know how they implement it, for example. And to be fair, like, this is maybe implementing things this way is just the standard approach, but I just remember myself not doing things this way the first time and running into all sorts of problems. So I think I found it to be a really important insight for me. So
yeah, and I can also see how you gave me that thought while I was listening to what you had to say there, that when you have it all in one code path, you see these things side by side. I could almost imagine like it, to make a sort of abstract example, if you're implementing a virtual machine for a bytecode you're inventing, and you threw in a new instruction that actually does the exact same thing as a different instruction, but you just like you convinced yourself it was different because like you'd ordered the parameters different, and you thought actually you ended up implementing the exact same implementation code inside the case somehow without realizing that's what you were about to do. When you set out, you would just eliminate that redundancy and be like, no, okay, like, in x64, like load effective address is essentially like an add and a mul for certain cases.
Right.
So we don't also need like an accelerated multiply by powers of 2 that goes up to 8 because that's already in there and just by a different name.
Yeah.
But like I could see how the same thing would happen when you're looking at the click path and the drag path, and you're just scratching your head going, wait, there's a click, there's a hold period, and there's a release period. Things change at each. All of that is the same. Why is this two separate opcodes in my VM? Where by opcode I mean feature flag, and by VM I mean UI system, but same basic like thing. You've got it all in one spot, and you just see redundancy immediately. Whereas if you had a button.h and a slider.h, you'd probably never notice, or it feel like the comparison, undoing that splitting out would actually be a lot of work too, because they're already so far apart and like spaced out by all this boilerplate, whereas in your style they're literally just two ifs separated by a blank line, which is the easiest thing in the world to dedupe if you notice they're duplicated.
Yeah, and I think also in that case, like, even if you wrote, button.h and slider.h, and they're both implementing these different widget patterns in a top-down fashion, it's not even just that, let's say even that you wrote the clickability path in the exact same way in both cases. Those code paths could also differ in very small, irrelevant details. And so, like, as code sort of, if you have two pieces of code that live apart from each other, and they're not, it's almost like a evolutionary thing. But it's like, if you have two pieces of code, they're evolving separately, and you're incorporating constraints into each one as you need it. Those two code paths, even if they started the same, will just slowly drift apart, and it'll be harder and harder to imagine that they'll be merged eventually. But if you force them to be in contact with each other all the time, then it's like, that they're going to evolve correctly, because you're like holding them there. Like,
they're in the same environment, so they're not going to develop like their own niches with their like different adaptations. To use the evolutionary analogy makes some kind of sense, like the divergent species. I'd have to play with it to see the way that analogy maps in, but yeah, I like that. That is cool. Okay, I want to ask one more question about this, because we've talked about top-down versus bottom-up design for a while, and I have one last question, which is, I think there's a lot of folks who have followed your blog post and other things you talked about and have learned specifically a lot about how like the UI thing works, but there's also probably still a question remaining, which I think would be cool to address now, which is, imagine I'm not writing UIs, we're going to just completely separate it from that use case, but we want to take this bottom-up versus top-down thing. How do you suggest determining when it's appropriate to engage bottom-up thinking? And as a follow-up, if you're trying to figure out if it's worth it, you're also often in a situation where you kind of have the top-down thing there and it's sort of kind of working but sort of not, and you're really not sure how you would start doing bottom-up design if it's not something you're familiar with. So what would your advice be to someone who's in a like just generic context, not necessarily UI, trying to engage in bottom-up thinking and not being sure where to start and how to evaluate that decision?
Yeah, that's a pretty difficult question. It's hard to answer without reintroducing the context, I guess. Because I can give other examples of context.
I'd be happy to look at an example. I guess the main part of the question I want to focus on is that decision point to like here's another way I could make it very specific for you. Do you have some kind of sense, like what is the experience, the alarm bell, the thing that helps you to notice when the thing you are doing could be more bottom up and that you would like to do that? Like what does that decision point look like for you in your process?
Yeah, man. I mean, it's not very like rigorous or obvious, I suppose, but I think what ends up happening is anytime I'm trying to grapple with a problem, and this problem's solution necessarily requires many different manifestations of like fragments of my solution working. I'm just like, I don't know. The way I'm going to phrase it is be like, well, yeah, obviously you would do what you just said, but if I'm trying to like grapple with this big problem space, and there are several things that this solution must produce. So in the case of UI, it's like there's like unbounded numbers of widgets you might want to produce with this kind of system. And the other example I had in my head was like video game entities. Like this is sort of like the reason partly why I started thinking about how to program this way was seeing how Casey did entities in Handmade Hero. And applying that first to my own like entity ideas in my games. And I was like, oh yeah, like this same principle works in UI too, and I think the principle applies because you are trying to, you're dealing with a space where there's a lot of different effects you want, and it's too economically expensive. Like you don't have the time or don't resources, or if you went and spent all the time, it'd be like very little bang for buck. Like you would have wasted a bunch of your time. implementing each feature independently. So I used to write, for example, when I was building video games, I would have the same exact sort of feeling creep in. I just didn't know how to address it at the time originally, but it was sort of like I'm trying to build like entities in this game, and I know that there's like a ton of different possibilities, and I set up all these systems so that whenever I come up with an idea for a new entity, I can slot it in easily or something like that. But then the problem ends up being I need a new entity kind for every single new style of feature or new style of entity that I want or something like that. And same thing happened in UI. And I think what ends up firing off in my head is like, if I've written a code path that solves a problem for a subset of the cases that I care to handle, and I'm trying to think about how to extend that code path to like incorporate new constraints, like, oh, there's this other effect that I wanted out of this that I'm not getting. And it has like, there's some parts of that problem which seem to have been also in the first problem, and there's a way to like draw a line between this feature working in the original solution and that same feature working in the second solution. Then you can imagine saying that that's just one feature and it applies in both cases. And maybe if there's unique parts that end up coming out of both of those cases, then maybe that's just a feature that one of them has on, but the other one has off. And so, I don't know. It just feels like,
yeah, it's tough not to crack. I will say, I feel like I have a very similar understanding of top down and bottom up to what you have. I think that my framing works quite differently. I think a lot more in terms of like non-pragmatic things, like you're talking about feature code paths and flags, and I would be talking about axioms and the way things are defined in mathematics and how it's
right.
like versus how things are defined in like a linguistic way, and like the push and pull of these two different universes. But it's like the same basic conclusions we tend to arrive at by these ways of thinking about it. And I think that indicates to me that it is a sort of whatever path a particular person uses to get there is not the only way of getting there and understanding it, but it's one of those things that it is just sort of, it is kind of profoundly true that this is a better way to do lots of things. It's like, it's what you, until there's a period in being a programmer where you know how to do the top down thing and it feels useful, you can do stuff, but there's a sort of huge difference between knowing that there's an ideal solution, but not knowing that you would be able to recognize it when you saw it, and then having this realization and going, okay, now I can be quite confident that I'm actually building this thing in a way that makes sense. Like whether or not there's a further path, which is then like, how do you generate these ideas from scratch when you're getting stuck? How do you back off and come up with a top down idea or a bottom up idea, right? But before you even get there, there's another issue of just how you recognize it. And I think we all kind of get there by our own path to a certain extent, of like how you notice when things are working really well versus when you're having to write a whole new piece of code for every little thing that feels like it should be a trivial modification of what you already have, but is actually just tons of new code every time, right? Like there's a clear set of things that are true about the code that does not grow in complexity like that. But how you characterize it is quite difficult to characterize in a way that you can confidently explain to someone else, or that you can help them to see what it looks like too. And I think that's kind of I guess maybe a good way to frame the question for you, if I take one more shot at it, and whether or not we crack the nut on this attempt, we'll move on. But if you were to go back, and I don't know if it's like the Melodist or different game development stuff you were doing sort of in the period you were referring to where you hadn't fully sort of seen how to think this way, what would you tell that previous version of yourself to sort of help that? What was the thing they needed to make one step forward, that previous version of yourself that was stuck in the rut of not knowing what would make it work better?
Yeah. So I think for myself in particular, I was very, and I think that thing that I mentioned earlier about wanting my cake and eating it too, I think it was that same instinct in the previous version of myself that was causing me a lack of progress. And that was basically not willing to be any less than exact about what it is I was doing at any point in time. So I was like, in the Melodist, for example, I had these like birds, and these birds would like fly and make notes and stuff. And like, I would not have ever settled, like, if per bird I was storing something that no birds could ever possibly have, I would have like not accepted that. I would have been like, nope, that's not, like, that's a different data requirement. Like, it's clearly a different problem. And that it's sort of like missing the forest for the trees, because like there's a million ways in which birds are the same, actually. Like, for example, if you're building a level editor and you want to draw a rectangle around the thing that the user has hovered, and you want to like display the ID, or like, you know, you have some universal ID system for all your entities or something, then that's a way in which a bird is the same as a tree. And like, that's the way that a bird is the same as the player. And you know, they can, if you wanted some in-game event to like activate some ID, then, and you know, maybe before you only thought you were activating characters, but now you wanted to also activate a bird or something like that. I think what I would have just told myself back then is like, I don't know. Maybe I should just be concrete. It's like, look, it's okay to waste some memory, and it's okay if you build systems that like produce the effects that you want, but also make sure that they can produce effects that you didn't think you wanted originally, or something like that. And I don't know. I mean, I think at some point I gained some intuition about like, when you introduce type system boundaries, you also introduce code boundaries, and that necessarily requires your code to fragment. And if you're writing lots of unnecessary code, maybe it's because you're introducing type boundaries when you shouldn't have. And I don't know. It's hard to be more. It's trying to bridge the gap between like the really profound mental model that I feel like I've gotten to, and like the very obvious stuff where it's like, well, yeah, I don't know, it's fine. But
yeah, the very profound stuff is like, makes sense to the people who are already over the hump, and the concrete stuff makes sense to everyone, but in two different ways, right? Like, to the person who's over the hump, you're like, well, yeah, because that's that whole thing, like that's the bridge to the better way. But then to someone who's just listening to it, it's like, yeah, you're just like stating obvious stuff. I don't know what to do with it. And it's sort of, it's frustrating because it's in a way becomes obvious when it's one of those things that becomes obvious when you see it, and yet it's possible to miss for a while. So it's like trying to point at something, it's not even like subtle, but it's easy to overlook somehow. Right. So anyway, I think that's probably about as helpful as I think you've been pretty helpful. And that's about as much as I'll try to drag out of you. Trying to figure out how to help anyone out there listening to this. So I think for a final topic, I'm going to kind of shift gears now. There's one thing you and I have in common, which is an interest in changing the entire environment of how computing is done. And there's a small allusion in your blog post. Would you mind reading that section from the end of part 2 where you talk about programming environments and programming languages for us?
Yeah, so I said, I'm of the opinion that in current programming environments and with current programming languages, immediate mode user interface APIs get closer to achieving the goals and constraints I outlined in part 1. Someday we will probably find a way to do things in a better way, but for now the techniques I've presented have been very useful to me, and I hope they're useful to you also. So that was that paragraph.
Yeah, so that's the part that to me, it strikes me as an allusion to the sort of like non-textual programming world, which I mean, you can correct me if that's not what you meant. You also mentioned programming languages in there, but it is it does sound like the kind of thing that I tend to think of as, once I start hitting certain boundaries in the ways I can do things, I make trade-offs that I wouldn't have to make just on the constraint of the CPU, but I do have to make it on the constraint of the editor or the compiler or something like that. And I assume that's kind of the part you're talking about there, right?
Yeah. So it was a very general statement, so I'm not exactly sure what I was thinking at the time, but I do know one way in which it applies. And I think to maybe frame this in a good way, I could start with basically just like what user interfaces fundamentally are, which is just all the machinery that facilitates communication between a human and some software system. And so the software system is doing something other than UI. Like it's doing some useful work, hopefully. And the human is like this independently operating like machine that's having to communicate with the software system. And the UI is the thing that facilitates that. And what everyone who has written UIs from scratch probably like realizes at some point is like, there's just a lot of resources that are spent on facilitating this communication, and it's not even the thing you were building the software to do. Like it's purely just to drive computation at the hands of the user. And so I think maybe one of the things that I was thinking there was, so in part one I talk about why it'd be useful to minimize builder code. And it's because it kind of gets out of hand in a lot of cases. It's just like there's just so much stuff. There's so many options, and you always have to write new builder code because there's just always extra UI constraints popping up. And I think this comes down to the fact that ultimately what you are providing the user is a means to control computation in some way. And I think what I meant by in future environments, this might change, is that at some point I think we'll start to see the boundary between using a user interface to control computation and using a programming language to control computation. Those will probably get a little bit closer together, if not merged entirely, maybe in like 100 years or something. And I think the reason I think that is because currently what a user interface allows you to do is a very limited subset of computation for whatever purpose that someone had in their head. And so even in the context of a text editor, the text editor is not the thing letting you build and run the programs and everything. It's just the thing that's letting you do the limited subset of computation that it takes to manipulate a text file in some way and then save it out to disk and like do the things that a text editor does. And so I think ultimately what more powerful computing tools will look like is offering larger and larger spaces of computation available to people in the same way that programming languages did. And a really good concrete example of this is just Excel. When you use Excel, you probably don't think you're doing programming, and you don't think you are doing things that programmers once would have done, but you are. But you just think you're interacting with some user interface. Like it's just like, I'm just here typing numbers into these cells, and like, yeah, they know how to refer to one another and everything. But you're ultimately doing computation. It's a much larger space of computation than other applications allow you to do. And so I think what you'll start to see is user interfaces. I think you'll start seeing them eat away from programming as they become more and more powerful. Now, I don't know exactly what shape that's going to take, but I think at that point it would be like it'd be weird to call that kind of a system. Like if the user is ultimately writing something like the analog of code, then it'd be weird to call it immediate mode or retained mode or something. It's like the user's just creating stuff. Like it's almost like it seems more retained mode if you think about it. It's like, no, they're creating something and deleting it, but it's like, but they're the programmer at that point. So in the same way that when I write immediate mode code, I'm doing retained mode, I'm interacting with a retained mode thing, like I'm creating text or deleting text or something. Like there's this like retained mode idea, this stateful idea that I'm dealing with. And I think at some point non-textual programming tools will feel more and more like a user interface and less like a text editor. And with that advancement, I think a lot of builder code will fall away. So especially a lot of debug code or like visualization code, or I mean, a lot of the stuff, just a large portion of builder code actually that you actually have to write. Now, maybe someday, if you're in this magic environment where like, your changes in your code are like automatically applying in this running loop, like live code editing environment or whatever. And everything's graphical and like you barely ever have to write user interface code. You might still have to if you're building a game and you need like a very specific limited subset of computation, in which case the whole point of a game's interface is like not to be this Turing complete amazing computation machine. It's meant to be like, here's your inventory or something like that. And so, it's not like that kind of programming is ever going to go away, but I think like a large portion of what we write builder code for today will probably just stop being necessary at all. And so at that point, it's like, this isn't, you wouldn't think about it in terms of like, that's immediate mode UI or retain mode UI or anything. It's like, well, no, everything, all the visualization we ever wanted from immediate mode UIs just falls out of the system naturally. And so there's no point in writing more immediate mode UI. Like, it's like a nonsensical question at that point.
So if I could like paint a little bit more specific of a picture of kind of what you're envisioning UI construction might look like in the future, it sounds like you're saying that as this line between using a UI and programming blurs, that it would become possible for a code path that, you know, you could imagine appearing in immediate mode UI, where you have a button inside of an if conditional and then some effect inside of the block in there. So like that's like the classic example of, you know, it's immediate mode when you write if do button curly brace something happens, right?
Yeah.
And it sounds like you're imagining a sort of transformation of that into, I manually manipulate sort of like a Visual Basic form editor type experience where I'm like putting the button in where I want it to go, and the code that is going to follow from that is something accessible like a spreadsheet kind of programming interface that I don't actually have to open up my C editor. Like in Basic, I don't know if you've ever used Basic, but in Basic what you would do is you'd like right click the button and it would jump you to a method of some specific class derived from the button superclass, and then you would implement the onClick method for your special button using the Basic language. And I'm imagining you're not talking about that. You're talking about something where behind that button is more of this same for lack of a better word, like core node structure kinds of things. The same way your UI is built now, probably more or less an entity system or a set of interacting entity systems where, yeah, I've placed the button where I want it, I set the text on it, and then I kind of go to the tab where I set out the thing that's like the Excel spreadsheet, but not Excel spreadsheet, but the whatever represents the computations that connect back in with the rest of the whole system whenever that button gets clicked.
Yeah, so I think getting into specifics is obviously really difficult because I haven't built this system and nobody else has, and it's like hard to start imagining it. But I think there's some. I wasn't thinking of it exactly in that way, but I think I think you're onto something though, and I think it's related. What I was sort of thinking more is that, you know, if you, in the simplest case, if you imagine like the classic IMGUI example, if do button text and then like block of code, what you can imagine is if a button, if the equivalent effect of a button were one trivial effect that arose from the computing environment itself, then what you would have is that ultimately, like the button on screen and clicking it and this code path executing, it would be identical to the concept of a function call in a live programming environment. So it's like the fact that there's a button here is just the way that this code is like code in this code with air quotes in this environment. The fact that it's laid out like here's a button and this runs this code path or whatever, that's just another version of code inside the same environment. So it's not like there's a UI layer and this code layer. It's like it's a uniform structure where where a button is sort of like it's as if it's a function call that's triggered by the user clicking it or something like that. So it would be equivalent, for example, to you have a build script. And the build script does this big batch of work, like preparing some stuff for you to ship to people or something like that. That might also just appear on screen like a button or something like that.
Right. So you're actually taking it a step farther than I was, which was I had blended together the concept that I have a UI-based experience with programming, but I was still projecting a UI preparer who would prepare a UI and pass it off to a UI user. And what you're saying is, no, the UI user is just loading up the coding environment. Like you're taking it like you completely eliminate the distinction between a UI preparer and a UI user. The person who wrote the code that you want to run just ships that to you and you've got a button to click.
Yeah, right.
Yeah,
Yeah.
I see. Yeah.
And I think like when it comes to the visualization stuff that I was referring to, so a lot of builder code, I find when you're building games or something like that, you write so much code just to like put something on screen so that you can play with it at runtime and like tweak these variables, or like let me see what's happening in the profile, like visual, and especially like turning on debug rendering features or something like that. Like there's just like all this extra little various UI stuff where you don't want to like shut down the game, go to the pound define features, and then like turn that one on, rebuild, run, get to the same spot you were before, and like no, you'd rather just turn it on at runtime kind of thing. I think that all of like when it comes to the extra visualization features that you write, or the extra like controls like tweak this state at runtime kind of thing, I think that one way that people could see that effect coming out of UIs now is with like some version of like the node data flow kind of stuff, where at each step you can inspect exactly what the visualized result is, like, and you can take like, oh, this node is feeding into this other chain of computation, but like feed that node into like this visualizer thing. I'm not saying it would be a node graph, but I mean, that's one example of how you write code in this system and you get these intermediate visualization steps almost for free. And then the person who had to write like the basic visualization primitives had to do that once. Then you get visualization for all of the code that's written within that system. I think the same thing could be obtained at like systems programming level. Now, I don't think that probably not without participation of the operating system. So like the full-fledged version of this where like all this just works magically is like I said, like 100 years down the line or something like that. But I think in special cases, you can sort of see this arise already, is the point that I was trying to get to. Like when you look at these special case node flow or node graph flow things, so that kind of stuff. So
yeah, I think I follow now. That's really interesting. It's funny that I don't know how to put it, but in none of these situations does the need to understand UI programming disappear, but you can see in a very meaningful way the importance of it vanishing, where like right now it makes sense for you to spend 9+1 blog posts giving your best effort way of to make this a tractable thing so that you can produce lots of UIs. What your long-term vision is that you don't have to, like, there's zero code involved, like for everyone except a handful of UI programmers. Like you almost do long for a world where a few reusable UIs get built and we are all free as programmers to build applications without ever touching UI programming because of the way the environment is structured.
Yeah, for sure. And and ultimately you will have people who have to think about the problem of UI at the bottom layer, like people who are building this environment sort of need to be worrying about that kind of problem. And of course you still have, like I was saying earlier, when you're using any interface that's not designed for empowering the user but constraining the user, like in the case of a video game, or of course like very special case, like, you know, this is a user interface for someone to very quickly submit this form to us and we don't want them to have to fiddle with this computing environment. Like we're building this special case thing, like, but ultimately that would be a special case of this general environment, like sort of trimmed down. Yeah, so that's probably what I was thinking of in that blog post. And I don't know, like, obviously I could be wrong about everything. Like maybe it's not the right way. Maybe maybe it'll never happen. B, maybe it shouldn't ever happen. But C, I think it sounds pretty cool. And I don't know, it'd be an interesting development for sure.
Yeah, it does sound cool. I think it'd be worthwhile to someday have another conversation, which is, I think with a lot of this stuff, something where my head is going with a lot, and I'll just leave this with you and the audience to think about for now. But in the process of thinking about computing environments of the future, I'm looking for ways to guard against the danger of chasing a thing that you don't have any reason, like figuring out how to decide what's worthwhile to invest in the lack of evidence that it's possible to achieve what you're envisioning, right?
Right.
And what I've been toying with is trying to figure out, can you envision without having a story about how it ends up being constructed and how you get to the point where you have the environment and the right style of UI design and programming interface and like the cooperation from the operating system and all of those things tied together. Because that's sort of like building a flying machine that self-perpetuates, and how you get to that part is sort of a separate thing. But is there a way to envision the steps of computation, or is there a way to break? I'm starting to try to play with the idea of just once you imagine that self-perpetuating thing working, you should be able to still map that all down to things a CPU can do. Right. And if that's all in principle possible, then you just have a question of like, how do you get it all work? How do you scaffold this thing properly? But yeah. I don't know if that's something that's definitely not something we can explore now. So I'll leave that with you. I don't see any really strong, obvious reason why it doesn't seem possible, but that is sort of the best thing I can come up with to test it, which is what can you map out the entire path of a computation, like the computation cycle here, from a user interaction to stuff happens to it comes back to a user in this system. And if you can map that out, then you've got the blueprint or the path of like one way it would work once it was all self-perpetuating this flying machine thing that has all the pieces it needs to do its thing.
Yeah, no, for sure. That makes sense.
So anyway, I think that's about everything we have to talk about today. Thanks so much for coming and talking about all this. Super helpful and super interesting. And I don't know if there's any more. Is there any more UI blog posts coming, do you think, or is it mostly wrapped up?
Yeah, I forgot to answer that. I haven't come up with another. There's a bunch of problems that are adjacent to UI programming that I think I've got a good story about that I will write about at some point. Namely, like kind of like the rendering post, which ended up making it into the series. I've developed my opinions on like text rendering and doing that in a way that I feel pretty good about at this point. And I think there's a few other things like that. Like, what does it take to just if you're only dealing with like simple languages like English, left to right kind of stuff, like how easy is it to do like wrapped multi-line text rendering easily with variable width fonts, and how do you get very crisp glyphs like using the native system libraries? What does that problem look like? There's some things like that. I don't know if they'll make it into the series proper. They're kind of like they start getting outside the UI picture. Other than those problems, I think it might be at the point where I don't have more ideas, but I kind of wanted it to be an open book so that if I was writing some UI code and I was like, oh, this is a really important lesson that I guess I wouldn't have thought of before, and it was really important for me to learn this, maybe I should put that into the blog series. So it's kind of open. I don't know if I'll ever like wrap it up officially, but right now it's not wrapped up.
Yeah, so I presume, though, that you do have other blog posts probably in the future, even if they're not the UI stuff specifically. You talk about all kinds of other stuff, arenas and issues with open source software and all kinds of interesting stuff. So I assume you've got blog posts coming. Where should people go to follow your blog and any of your other activities that you're doing right now?
Yeah, so if you want to look at my blogs, which included a variety of stuff, you can go to just rfleury.com, rfleury.com. All of my links to various other things are on that website. It's just my Substack. But you can also follow me on Twitter at Ryan J. Fleury, Fleury, spelled the same way. And yeah, I think even if there's no more UI stuff coming down the pipe, which I'm looking at my rough drafts, and I do have one thing labeled UI bonus post 2, but I haven't gotten to it yet. But even if there's no more UI stuff, I think there's going to be other adjacent problems coming down the pipe. So I think, yeah, if people are interested in it, they can go there.
All right. Great. Thanks, Ryan.
Thanks, Alan. Great to talk with you.